Hello, this is the final presentation for Team B9ME's Mechanical Solar Walker. As the world transitions to automation, clean energy, and space exploration, there is a demand for automated machines that are capable of carrying payloads, traversing unconventional terrain, and being able to be autonomous. The constraint for this project is to have a power bank carry a load, specifically have a leg length less than 12 inches or 1 foot, and be cost efficient with a budget of $650.
So we looked at a two-legged walker, a four-legged walker, and a six-legged walker. However, a four-legged walker powered by a solar battery appealed to us as the best design for our given objectives and requirements. In our feasibility meeting, one of the main concerns was manufacturing it because a too dense material such as wood can put much strain on the legs. However, to tackle such problem, we did a 3D print of the final prototype with carbon fiber, which provides a perfect strength to weight ratio. Also, the leg design was brought up in the feasibility meeting, suggesting to simplify it. However, we kept our design because it contains a 3 degrees of freedom. Taking away the servo motors from the leg would lower the degrees of freedom and therefore negatively impact the walker's ability to climb and overcome rough terrains. So for all these reasons, we decided to go for this design.
In practice, those design principles carried over in an ideal way. We have four legs that allows for mobility and stability under our payload, able to maintain our 3 degrees of motion, have enough space on our chassis for the Arduino board, the payload, and the battery, and incorporate our motors in such a way that we maintain the previously mentioned 3 degrees of freedom under material choice of carbon fiber.
So design process is divided into four parts: problem formulation, preliminary design, detailed design, and the manufacturing and testing phase. For problem formulation, we defined objectives that satisfy all design requirements. These objectives are a feasible and reliable structural design, selection of material with adequate material properties, select a solar battery with enough energy to power the motors, and select a computing platform to control movement of legs. Next slide. For preliminary design, we devised four major questions, and the answers to these questions were 4 legs, carbon fiber for design, 3 motors per leg, and an Arduino board for the computing platform. Next slide. For detailed design, we perform structural analysis and energy analysis. And for structural analysis, we simply provided evidence that the material properties and geometry can support the payload. And for energy analysis, we determined that the solar battery can generate enough energy to power all motors. Next slide. For the manufacturing and testing phase, the walker may be 3D printed at Rutgers Makerspace, and then we can just simply test the functionality and performance after final assembly. Next slide.
So we used the ANSYS software to run the simulations, and we simulated the maximum joint stress, the maximum walker stress, and the maximum deformation. Here is the simulation for the maximum joint stress, the maximum walker stress, and the maximum deformation. And these are the three main parts of the leg. On the left is the tibia, on the middle is the thigh, and on the right is the connector. So currently, our solar walker design is complete, and we have run the simulations, and we have decided not to manufacture in the spring. And carbon fiber, the material selected, is more than capable of supporting the payload, and the battery selected also fulfills the power requirements of the motors and the Arduino board.
And as you can see, this is the fall 2020 Gantt chart. These are important days throughout the fall semester that we noted, like assignments and important scheduled dates. Next, please. And then this is also the spring 2020 Gantt chart. This is just a predictive. These are predictive dates on what will occur in spring of 2020.